All right, these next two videos, we're going to start talking about sampling methods. So how do we get our sample, right? So if we want 5 different people to talk to, how do we get those 5 people? If we need two, two different chairs to look at, how do we get those 2 chairs? And specifically, what's a good way to get those 2 chairs, right? We don't want a flawed method. There's lots of flawed methods. We'll talk about that in the future. And actually, there's some that are very common that you see every single day, but it's actually terrible. But again, we'll talk about that later. So the only one we're going to be talking about for this section, so it's going to be a little smaller section, is the simple random sampling. Oh. So we say that a sample of n people, right? So 2 people, 5 people, whatever, from a population of a big N. So if we have 2 people from the population of people at a community college, or 3 people from the state of Tennessee, or 17 people from the nation, right? Something like that. So a sample is obtained through simple random sampling, provided that every possible sample of size n, little n, has exactly an equally likely chance of occurring. So all of these are going to be random, and we'll talk about, like I said, in the next video, we'll talk about more random samples, randomized samples. So just because it says randomly does not mean it's simple random, right? Randomly, if it uses the word randomly, that does not mean simple random. All of the ones we're going to be talking about are going to be randomly selected, but this is the specific way that it's randomly selected. It's where every population, right, every sample size has an equal chance of occurring. All right, so that's a little tricky, so let's give an example. All right, so suppose that a study group consists of 5 subjects: Jan, Patricia, Daryl, Bob, and Maria. 2 of the subjects must go to the board. List all the possible samples of size 2 without replacement. All right, so this is from problem 1 on the worksheets. So so we only want 2 people. So what are all of the possible samples of 2 people? So we can see that it could be Jan and Patricia, right? Those 2 could be going up. Jan and Daryl, Jan and Bob, Jan and Maria. So can it be Patricia and Jan? Well, no, because Jan and Patricia and Jan, that's the same group, right? So we don't need to worry about that. So it would be Patricia and Daryl, Patricia and Bob, Patricia and Maria, Daryl and Bob, Daryl and Maria, whoops, and then Bob and Maria. So these are all of the possibilities for a sample size of 2. So if it's simple random, right, we need to make sure that every single outcome has a possibility, right, has the same chance of getting chosen. Every combination of these 2 people should have the same chance of getting chosen. So let's look at problem number 2. So which of the following methods would be considered simple random? Choose all that apply. So for this problem number 1, let's look at part A. In consideration of gender equality, 1 male and 1 female are chosen randomly. So is that simple random? 1 male and 1 female are chosen randomly. So if we had 1 male and 1 female, right, we see that Jan and Daryl could be chosen. Jan and Bob could be chosen. Patricia and Dan could be chosen. Patricia and Bob could be chosen. Dan and Maria could be chosen, and Bob and Maria could be chosen. And those are the only ones that could be chosen, right? So does every combination, right, of 2 people have the same chance of getting chosen, have an equally likely chance? No, right? 2 girls could never be chosen. 2 boys could never be chosen. So because of that, it is not simple random, right? Because 2 girls cannot be chosen. right? Or you could say because Jan and Maria isn't an option, right? And all of them have to be options. They have to have the same probability of getting chosen. All right, let's look at part B. Each person's name is written on a slip of paper, placed in a hat, and 2 names are drawn. All right, so if we put everybody's name on a slip of paper and pull them out of a hat, right, is that going to be okay? Yeah, I mean, every single possibility could be potential, right? There's no combination of 2 people that couldn't be chosen. So in essence, every combination of 2 people have the same chance. Now remember, it's not that Jan has the same chance as Daryl, it's that Jan and Daryl have the same chance as Patricia and Bob, right? Every combination of 2. So yes, this one would be simple random. Oh, hold on. There we go. 2 people volunteer to go up to the board. 2 people volunteer to go up to the board. So, are all of these equally likely if I just ask for 2 people to come up to the board? So, some people might think yes, but let's think about it a little more. So, if we were actually sitting in a classroom and I right now said, who will come up to the board and do a problem for me? There might be some people who are super eager, right? They immediately raise their hand. Ooh, I want to go, I want to go. There are some people that will wait a couple of minutes and we will just sit in awkward silence. Yep, like this, just awkward silence. And eventually, someone may just, because they want the silence to be over with, they, timidly raise their hand. And then there are definitely some people who we sit in silence and there is no way in hell they're going to get up to the board. They will sit there for the entire class period. You are not going to get them to volunteer, right? Oh, they will call your bluff and they will sit there for 80 minutes or 2 hours. They're not going up to the board, right? They will stay in their chair the entire time. So, because they're all different types of people, right? Is everybody have the same chance of getting chosen? Every combination of people have the same chance of getting chosen? No, right? Because the people who would never go up to the board has a very less likely chance of getting chosen than the people who would more eagerly or at least hate the silence, right? They'd go up to the board. So, volunteering is not a simple random method, right? No. We could say, because some people might never volunteer, unlike other more willing people. But either way, it's not the same probability, right? If Bob will never raise his hand, but Jan and Patricia they're cool to eventually go up to the board, right? Then Daryl and Bob don't have the same chance of going up to the board as Jan and Patricia, right? So not the same chance, so not simple random. Part D, each of 5 people are randomly given a number 1 through 5 and lets their calculator choose a number randomly. So if you give everybody a number, so we can say Jan is number 1, Patricia's number 2, 3, 4, and 5, right? And the calculator just chooses 1 at random. Would that be simple random? Does every combination of 2 people have the same chance of getting chosen? Yeah, I mean, this is essentially the same thing as part B, right? Just choosing names out of a hat. Yeah, so we haven't eliminated any options. Everybody has the same chance of getting chosen, so that would be simple random. Part E. To encourage women in the STEM program, so science, technology, engineering, math, 2 women are randomly chosen. So, is this going to be simple random? Well, it says randomly, so yes, obviously, right? No, remember, I said just because it says randomly does not mean it's simple random, right? Simple random is a specific type of method to get it. So, 2 women are chosen at random. So that would mean that Patricia and Jan could go up to the board. Patricia and Maria. Who else? Patricia and Maria. Oh, Jan and Maria, excuse me. Yep, those are the only options, right? So is this going to be simple random? No. There are so many combinations of people that can never get chosen, right? Two men can't get chosen. A man and a woman can't get chosen, right? Yeah, so even though it says randomly, it is chosen randomly, but the way that we're chosen, we're eliminating some possibilities, right? So no, we could say because a boy and a girl cannot be chosen, right? Or you could say because Jan and Bob cannot be chosen, right? You can give one possibility. That works. If some do work and some don't, then it's not going to be simple random because not everybody has the same chance. All right. We'll talk in the next video about maybe if this was a little confusing, that's totally okay. I'll give you kind of a secret answer, a cheat kind of way of figuring out simple random. Simple random is a little harder to figure out. So if this was confusing, don't worry. Hopefully by the next video, you'll understand a little bit better. As always, if you have any questions, definitely let me know.